Welcome everyone to the July meeting of the Charlotte Tableau User Group. For those who don't know, my name is Rashid Manat. We have William Aubrey with us today. Jeremy Poole may or may not be able to join, but we have a special guest speaker today. One of our fellow Tableau User Group members, Darrell Pate, and he's going to give us a great kind of demo a little bit later on of how to explore geospatial data in Tableau. So looking real forward to that. But few housekeeping things right up the top. For those who who may not know or are new to our meeting, and we'll come back to this poll too. And we'll actually maybe have a little bit of time to talk about it at the end, for next month's meeting, kind of which one we might go with. But for those who don't know, the best way to follow us, to keep up with all of our content, anything that we produce, any kind of documentation, any kind of previous videos, virtually everything that we produce can always be found at the URL that I'm showing right now. And that is usergroups.tableau.com/Charlotte. Again, you can find content around future meetings. You can find content around our YouTube channel. You can find content around our Charlotte community forum page. And that's a good segue because for those who may not know, the Charlotte Community Forum have changed since last month. I believe it was around the end of June that the entire site was upgraded. So the entire community forum looks a lot different now than it used to. It's a little bit more intuitive, kind of a lot better than what it used to be. And feel free to check it out. But I say that to say the links have changed, meaning if you had previously bookmarked this link, or for that matter, any community forum link, they're now a little bit different. So that's something to keep in mind. And that actually leads to a quick kind of FYI for those who may not be aware of this. When the forums changed, old forum links are still technically not working. And what I mean by that, I've just done a Google search for Tableau parameter actions. This is something that's now in Tableau, but it used to be one of the most requested I guess enhancements you could say, for like almost a few years. And these are all just old community forum kind of, questions and answers and articles and so on and so forth. If you click on any of these, you are going to get something that looks like this. And it's across the board. Tableau is aware of it. They are working on it. Just kind of stay tuned, but know that these old links, what'll happen is if you do a Google search and you find maybe an article or a forum link that, had some useful information, it's not that it's gone. It's just that the URL has changed. What you really should do, go to the new Tableau community forum site and then search for that inside the actual forum itself, as opposed to trying to do it in Google or Bing or some other search engine. But again, they are aware of it. They're working on it, and hopefully it'll be fixed, like I said, very, very soon. Last thing I want to always kind of remind people of is that in addition to our YouTube channel and our community forum and all of other content, we do have our newest sections of our user group page, which is the Tableau short section. And this is a perfectly good example. When the new forums were released, Tableau introduced a bunch of videos that walk you through the new forum sites, how to join a forum, how to search the new forum, how to submit a question on the new forum. Again, the whole point of what I'm showing you here is when Tableau posts videos explaining very useful information, we will kind of, link to that content here. So anytime, there's any kind of videos we think would be useful for you guys to know, it'll always be in this Tableau short section. And another segue is our best of VTUG. I can't emphasize enough how much other Tableau user groups are producing extremely valuable content. It's so much content that, like I said, it'd be impossible to keep track of all of it. But whenever we actually watch something from our counterparts in other areas and we find it useful, we actually upload it to our site just so that people can also get that same benefit. So I'll give you a perfect example. In today's session, we are talking about mapping. There were two things I want to call out from some of our peers. One was around the DataFam Community Jam back in May. Louise Shorten from the Dublin, Ireland TUG did a phenomenal presentation on buffer calculations. I'm going to give you an example of a buffer calculation today, but she gave an entire kind of like 1 hour kind of session dedicated around it. Another example was actually, I believe, let's see if I can find it here. Yeah, the North Texas Tableau user group did a session with Cesar Pico around how using Mapbox and Kepler GL when it comes to some of the mapping that he was doing. This was another phenomenal session. I can't encourage you enough to watch it. And Tableau actually themselves did something this month. They did a 3-part webinar all around mapping. And again, with that whole theme of us centralizing content, we have a link in here, which is our favorite Tableau resources and links. And you can find the link to that session. It's called All Over the Map. Again, it was a 3-part webinar session. All 3 parts were very, very good. A beginner's guide to mapping, mid-level, and advanced mapping techniques. So again, I can't stress enough, these are all useful kind of materials to take advantage of if you can. And again, all of it's centralized. You can find all of this stuff at our main page, which again is always usergroups.tableau.com/Charlotte. Okay, with that, I want to take a second to talk about today's session. Today's session is going to be about geospatial data and geospatial mapping. And Darrell's going to give us a really good use case example of kind of what that is and kind of how he did it. But I'm going to give you about a 5-minute kind of overview of just what is geospatial data and why would I use it in a Tableau dashboard. And I'm going to show you an example that I did earlier this week as kind of, a use case scenario. So what I have here is a little spreadsheet that I created. And at the end of the day, this is light rail stations in Charlotte. These are all of the light rail stations currently in Charlotte and the latitude and longitude of the actual stops themselves. And there's a little indicator because there's actually some future stations, some of the ones that I believe are going to be in Huntersville, because this was all available in the file that I got. So I've got this file here. It's got my light rail stations and it's got latitude and longitude. What I can do with something from a geospatial perspective is something like this. For those who don't know, this is a great site, data.charlottenc.gov. It's just a bunch of data related to Charlotte. And I'm going to give you an example because there's a lot of spatial files, a lot of shape files in this, that are available to you. So I'm going to look up this data set called existing shopping centers. And what this is actually basically kind of what you see here. It's just a data set around shopping centers in the Charlotte area. And it is, or at least actually it could be downloaded as a shape file. So I want you to pay attention. All of these dots represent a shopping center somewhere in the vicinity of Charlotte. And if I were to download this shape file, what I would get basically are what you see here. This is kind of what the table would look like. I've got some ID numbers, I've got the shopping center name, a classification, and this thing called a global ID. This would be a good use case to say, is there a way for me to connect this information around shopping centers with my information around light rail stations? Before, this would have been really tough to do. There's no field here where there's, that I could join on. It's not like I can join on city or state or something like that. If you notice, all of these fields are unique. There's nothing that these two data sets have in common. But with geospatial mapping and buffers, I actually can pull this off. And I'm going to give you an example of what that looks like. What I've done is combine those two data sets to say that basically within, a certain radius, is there a shopping center close to a light rail station? And this is something that's actually dynamic. So I'm gonna give you an example. Right now it's focused on the South Charlotte. I'm gonna kind of move it up to University, but you can see there are 11 shopping centers in South Charlotte that are within basically a quarter mile of a light rail station. I'm gonna go to University because it's a little bit cleaner. And you can see in the University area, there's just 3. There's just these 3 here. It looks like J.W. Clay has Mallard Point Shopping Center. Tom Hunter has Northgate Shopping Center. And 25th Street looks like it just got this node at 28th Street. The beauty of this is I can adjust this radius. Notice that right now there were only 3, but if I increase this, circles get bigger and more shopping centers got added. Now there's 7. Now we picked up the McCullough station. It picked up, I think, 1 or 2 shopping centers in there. So this is a good use case example of why you would use a buffer, a geospatial join with a buffer calculation. And I'm going to do a real 2-minute kind of how, but Darrell's going to give you more of a kind of in-depth, kind of presentation around literally how to pull this off with the geospatial mappings and the shape files and everything else. But just to show you real quick how simple something like this would be, I'm literally going to just open up a new Tableau workbook, public, workbook. I'm going to do a join on a text file, and that's kind of where I'm going to get my light rail station information. So I've got my light rail station information. It's all there, kind of the way I expected it. One day we will talk about the noodles and the relationships and kind of how that works. But because this is 2020.2, it has that new noodling and relationship functionality. But I want to do this at what's called the physical layer. So all I did right now is just double click on that light rail, this kind of box here to get into the old joins, the traditional left joins and right joins. So this is where it gets a little interesting. I have my, for all intents and purposes, Excel spreadsheet with my latitude and my longitude. I'm going to add a connection, and the connection is going to be a spatial file. And I've already downloaded my shopping center shapefile, so I'm just going to kind of open it up. And then once that's done, okay, this is kind of what we expected. This is what I was describing. I've got two different data sources and really no fundamental way to join them, because remember, they have no fields in common. So the way you do this is that I want you to pay attention to this. Right now, I haven't chosen any fields on the left or the right, but I want you to see what my my operators are. I can choose a field on the left, choose a field on the right. I can say equals, not equals, greater than, less than, pretty much what you'd expect to see. But if I go to the shopping center file, which again doesn't have much, but because it's a shape file, it creates this geometry pill in Tableau. And this is important because if I click on this geometry pill, I want you to notice that, actually I don't have it yet, but what I want you to notice is that when I create my join calculation over here, there's going to be a new operator, because right now I'm not going to do an equals or a not equals or a greater than or equal, and I'm going to do what's known as an intersect. And let me kind of explain what that is. I've got my geometry file, and this is basically the locations of my shopping centers. But on the left side with my light rail stations, what I have is latitude and longitude. So I need to do two things. Latitude and longitude are too many points. I really need to make this one point. I need to just take the latitude and the longitude and combine them so that Tableau creates a point. So I'm going to use this make point function. And I'm going to say, I want you to take the latitude and the longitude. Now that's the latitude and the longitude of my light rail stations. So once I've done that, looks like I got some extra stuff in there. Okay, now this is just part one. This would create a point for the light rail station, and again, I have a point for the shopping center. But what I need to do is create a radius. So I'm going to use this new feature called buffer, and with that, I'm going to write that I want you to buffer my light rail station. My geometry is going to be this make point, and what I want you to do is create a radius. Let's say 0.25. So that's going to be 0.25 miles. And you can do miles or kilometers. I think you have a few options with that. But now that I've done this, now I've got my joint calculation. What this is going to do is create a 1/4 mile radius around the light rail station. So I'm going to say okay, and now voila. That wasn't there before because that wasn't an option before, but it's an option now. Now, if I do an intersect, what it just did, it connected the light rail station with the shopping centers only when they were less than a 1/4 mile from each other. And now I can kind of go into here. I'm going to have to create that buffer one more time to be able to use it in the visualization. So we'll just do that one more time. We'll say buffer. We will say make point. Again, we will say latitude and longitude. And if you have any questions, feel free to enter them in the chat or the QA. Either myself or William or even Darrell will kind of get to them as we go. So I'm going to say 0.25, and I'm going to say miles. And if I did that correct, and we're going to call this the Linux radius, if you will. Mess that up. Okay. And now that we've done that, it's created one of these types of geometry pills. I'm going to double click on it. I've now got basically what I expected to see. And again, with the mapping, you can use, kind of what I'll call maybe a more appropriate map. So I'm going to change this to a street map. And now you can see these are light rail stations in Charlotte, and they've got little circles around them. I'm going to create a dual access map. And what I'm going to do, I've got now the same thing on the top and the bottom. I'm going to go down to the bottom. I'm going to remove this. And now I'm going to go over to my latitude and longitude, my original ones for my, I'm sorry, I'm going to use my shopping center because I already did the latitude and longitude for the light rail stations. And I'm going to change this to circles, and I'm going to aggregate on object ID. So let's convert that to a mention. And now, like I said, we'll make that orange or something like that. And then we can make this dual access. And again, this is just kind of show you the orange circle represents the shopping center. The blue circle would represent kind of the light rail station. This is kind of ugly, but you get the idea, we'll zoom in a little bit. This is fundamentally no different than, like I said, if I were to clean it up, you can turn it into this. Now, here, the little blue icons represent the shopping centers and the orange circles represent the light rail station. But this was a geospatial join using a buffer calculation. Again, it's not as complex as it sounds. It's just kind of, different use case scenarios of when and why you would use something like that. So with that, again, if you have any questions, add them to the chat, add them to the Q&A. I will now pass it off to Darrell, and he will give you a much more intuitive example of, like I said, the geospatial joins and kind of how to use it and how he kind of used it in his use case scenario. And again, I'm Rashid Manat. Thanks again for your time. So Darrell, give me 1 second, and I will pass control over to you.
All right, sounds good. Thanks, Rashid.
No problem. Okay, you should be good to share, Darrell.
Perfect. All right. Can you see my screen?
Yes, we can.
Perfect. All right, so today we're going to be talking about mapping analytics. Rashid gave us a really good example about how to use some of Tableau's more recent functionality, a buffer calculation. And this essentially means you're turning a point into a polygon. You're basically taking that one point and you're expanding out from the center of it. We're going to talk about this from a beginner standpoint and then show how you can get to that example that Rashid just explained to us. So let's start with who I am first. I'm talking about mapping. You probably want to know a little bit about my background. So right now, I'm an analytics lead here at Wells Fargo. I do a lot of work with Python, Alteryx, and Tableau to create reporting very quickly and deliver insight very quickly as well. I'm a Tableau 10 desktop qualified associate, so I've been using Tableau for a couple of years. I'm certified, and in terms of processing the data, understanding what it is, and then presenting it in whatever medium, specifically Tableau, we usually handle the end-to-end process of that. And for those of you who are local to Charlotte, I am a UNCC grad. I started out as an intern at one of the financial institutions here. So if you guys have any interns that are starting with you right now, definitely invest in them. They can grow very quickly. So typically, what do I work on? Topical analysis. So what Rashid just talked about, analyzing at a local level, expanding up into maybe a state level or a county level, and then ultimately what everyone really knows about macroeconomics. Talking about what's affecting us, whether it be a national pandemic, counting COVID numbers, whether it be looking at the unemployment rate nationally, at a state level, and then more locally at an MSA or zip code level. Enabling enhanced analytics. So like we showed earlier, the ability to click around and dig in and get the answers to your own questions. And then enhanced reporting would be, how do you ensure that you can make sure that the report is updated or refreshed on some kind of cadence, or it's automatically refreshed to the latest and greatest data. Now, if you want to find me, these are the two locations that are easiest to reach me at. Twitter, I am DataDPate, and in LinkedIn, I am DLPate2525. So feel free to chat, ask any questions after the session, and I love to talk about data, so we can do it. Okay, so I'll give a primer of analytics. Some of you have seen my last session. I talked about this a lot, just to really orient people about analytics as a whole. There's three types of analytics: descriptive, predictive, and prescriptive. And a majority of us do descriptive analytics. What was the number before? What is the number now? Can we do some comparisons? Can we do some statistics about what it was last year? Can we do some statistics about what it is today? Predictive is more in the data science realm, going into the future. And prescriptive, based on what we have today, what we have tomorrow, this is what we would recommend you do. This is the action we recommend you take. And all of the analytics that we do today will be descriptive in nature. We're looking at what exists today. What does the city of Charlotte mean? What do these neighborhoods mean? What is the hurricane path for today? And ultimately merging that with the attributes that exist today too. Okay, so for mapping, the typical toolkit, I put this here for my beginners who are just starting out with mapping data. These are the top 4 tools that you'll typically use when connecting to mapping. Tableau, of course, most of us have that. And then there's a public version if you want to practice with some of the data on your personal computer and publish a Tableau public. I highly encourage you guys to do that. QGIS is a mapping tool that allows you to play with different kinds of mapping files, do some of the things that we talked about, a spatial join, intersects, joining data files together so Tableau can then use them after the fact. And before the latest update of Tableau in 2020 as well as 2019 with the introduction of spatial joins, the intersect function, as well as buffers with 2020.2, QGIS was typically the tool that someone like myself would use to transform spatial data before Tableau could use it. Tableau has really pulled everything in, so you can be a one-stop shop for your analytics, from data to visualization. Anaconda is a really good tool to get up to speed on. You can download it to your desktop, and it has Python already prepackaged for the most part. And Pandas and GeoPandas are really good tools to get the latitude and longitude of addresses. So say you have a CSV file with all of the addresses of Airbnbs. They may not have lat longs. So the ability to type some Python code or type some code in Anaconda really quickly and return those values is really valuable. I highly encourage you guys to do that too. And then all of us use databases, but with the new databases, there's the ability to do spatial SQL joins. That's not something we're going to talk about today, but from a long-term perspective, if you're talking about refreshing your data on a cadence, it's certainly something you should look into. Tools like Teradata, tools like Spark, you pay a lot of money for these databases, and they do have additional mapping features that are, from what I've seen, underutilized. So if you're looking into getting into mapping data, I highly encourage spatial database joins or spatial SQL. All right, so what about the techniques? What techniques are we going to be talking about today? Rashid gave a perfect introduction about what we're really going to be doing and has shown you most of the stuff that we're talking about today. So Tableau mapping since 2018 plus, the 2 biggest features for you to look up at a later time if you want to get more information are spatial joins. The first piece of taking a shapefile, seeing another shapefile, showing where they intersect, showing where they join. That's essentially what we showed before. And then the buffer calculation, taking a point, expanding that point out and looking at it in kilometers, feet, or miles. How far in each direction are we from other points? And the 2 functions that we could use to do this is make point and buffer, which we saw. So I want to give a little bit of context because some of us may be new to mapping as a whole. There's been a really good session on how mapping is done from a beginner standpoint, how to use maps if your manager asks you, as well as the advanced session. But to orient you, there are 2 types of mapping. One is a polygon and one is a point. A polygon is basically the entire geography. So you can see in my GIF here, North Carolina as a state, there are bounds, and those bounds have relationships. They can touch other states. They could cross, but we don't have states that cross. They can be disjointed. So North Carolina is not in any relation to California. However, it has a touching relationship to South Carolina. These are the type of relationships with geographic data. And then crosses would be something about a zip code. So some of us may know if you live on the North Carolina or South Carolina border, your neighbor may have a South Carolina address and you may have a North Carolina address, and you may be in the same zip code. And that's because that zip code or that geography crosses both the North and the South Carolina border. All right, now that we know about mapping, what is it? Really, we're going to talk about what are we doing? We're taking the polygons and points, and we're talking about the relationships. How do they interact with each other? So a spatial join, essentially, we're going to be taking either 2 two polygons and seeing where they overlap. We're taking a point and saying how out of the buffer that I have, how many points am I currently touching? And then for CSV file or something that doesn't really have geographic relationships, how can we create a geographic point so we can use Tableau's more advanced features with mapping information. So the GIF at the bottom is really showing, taking a spatial point, showing the buffer object, which is what Rashid did earlier, showing the radius that you're creating and what other points are you touching. You can count these points, you can give drill downs to them. There's a lot of additional functionality you can add on to it to make a dashboard really insightful and help your business users. All right, so now that we have a good overview, I'm going to talk about a case study that I had in my past, getting away all of the information that is proprietary and just talking about it from a public data perspective, because it can apply to multiple disciplines. So we're assuming we're an analyst, we're brand new to a position. Our manager has concerns about the hurricane season that's coming up. We're in July right now, about to head into August. This is around hurricane season. Of course, all of you know we're in the middle of a national pandemic. We're all at home, and this is like right around the corner. And in addition to that, from an economic standpoint, we're in a technical recession. So this could have a big impact if all of these three things combine on a business, whether you're in banking or insurance, whatever business you're in, this would be really good analytics to carry out. So what he's looking for, or what she's looking for right now, she's provided you a zip code database, and she knows that hurricane data is available online. How can we provide a tool that provides insight using geospatial data? And then if we're a small boutique shop, maybe we don't have the economic data, but we know it's readily available online. How can we implement a solution where we can get that data, but not have it exist locally? We don't want to refresh it all of the time. Maybe we have a very small boutique team. What can we do in terms of interaction that gives us the latest and greatest data? Cool, so we're gonna jump into it. With this, we can download the hurricane data. And the way that we can do this, take this out. The way that we can look at the hurricane data that we have, we'll need to go to NOAA, which is a website that allows you to look at the latest and greatest hurricane paths. And I'm going to look at Florence because this is the last hurricane that I remember that has touched North Carolina borders. It was a very devastating hurricane. It did a lot of damage to our coast. And this is a place that we can really look at the impact. So when you're looking at NOAA, the way that they present the data is two ways. If a hurricane is in progress, they will give you a quote unquote cone of certainty. And it's where they think the hurricane will go. And they update this projection for 5 days into the future, similar to how you would get your weather updates on your phone. So they're taking their Doppler radars and things of that nature, forecasting 5 days. This is where they think it will go. And they update that on a 12-hour basis and present the results essentially in real time. So if you're trying to analyze a hurricane that's going to hit in the future, they'll have that cone of certainty so you can identify what's at risk. This is just a simple write-up that's done after the fact. So assuming you're researching a hurricane in the past, there's a lot more readily available data about that hurricane. From what I remember with Florence, I believe it happened in 2018. So we have the dates here for August. And this report wasn't actually published until May 30th, 2019. It takes a long time to get the information about what damage did a hurricane cause, what were the statistics, what was the rainfall, what was the storm surge. However, you can be a really valuable data analyst if you can give a rough projection into the future. Hey, here's what we know the hurricane's gonna hit. Here's what data we have internally at a geospatial level. Here's what's at risk. So now that we have this PDF, let's look at the data. So we can look at Florence and hurricane AA. And on the hurricane site, they'll have a lot of different tools where you can look up different data that exists about hurricane paths. Sometimes they'll even have movies that show the hurricane as it's going to play through. You can also pull different types of data. So the cone of uncertainty that we talked about, that was available. You can get wind speed probabilities and look at where it's going to hit. Good thing is that we already have this downloaded to my laptop. So I'll be able to show you the cone of certainty and how that interacts with the CSV file that we discussed earlier. So we have those two things. We have our Hurricane Florence data. I've put the link here and I will send this out after the fact, but ultimately this is where you would go to retrieve this data. This shows all of the national advisories that were released for the cone of certainty, and these are updated as time goes on. These are shape files that can easily plug and play directly into Tableau. So no worries there. You could do this on your personal computer. And then the maps data set, maybe your organization has data at the zip code or state or city level already readily available to you. Or the other way, we can go to the internet or go to Google and essentially pull this data down. So we can pull all of the US zip codes. We can pull out the cities and states. These things do change over time, especially more at a granular level, like a zip code or a census tract. So really you can use the latest and greatest data. This is from February and this is a census year. So I'm sure this will change. It's best to know where you can pull the data from so you can always get the latest and greatest. So I've saved both of these here. And now let's jump into the tool. What does this look like when we put it all together? So let's start with how the data exists. And this is Tableau 2020.2. We did talk about how tables relate to each other or data sources relate. So what I'm going to do with the noodle view that's currently showing, and this is a brand new feature, what some of you who are using an older version of Tableau are more familiar with is the join view. So by double clicking that, we're able to see really a breakdown of what kind of files do we have in our Tableau workbook. And right now I'm using two shape files. I'm using the downloaded hurricane path, which I pulled, and then I'm also using zip code data about the hurricane. So this is essentially all of the little zip code points that exist within the US. And as Rashid showed earlier, we talked about how you can join these two things together. Now, in one shape file, if I had city and maybe I had some economic data, and in the other file, I had zip code and I had some economic data, maybe I could do a different kind of join and say where city equals city, join these two together. However, this is for essentially you're trying to join the shape. I know that Charlotte exists in North Carolina, but I don't have a CSV or an Excel that explicitly says that. So what we're asking Tableau to do is infer that from the location and mapping data that already exists. Makes it really easy for someone who's not a cartographer or not really used to using mapping data. And intersects will give you the point where these 2 points come together. All right, so now that we have that, I have an overview of what these two things look like. So our hurricane path, if I pull this off of the view, I have mapped out the entire cone of certainty. And these are over a specific point of time, this 5-day period. These are all of the points above the US that this is gonna hit. Now from a visual perspective, you can infer where things exist. You can say West Virginia and North Carolina. You can answer the question, did the hurricane hit Charlotte? And of course, Charlotte is here. However, if you're thinking about it more from a user experience point, what if I want to click on Charlotte? What if I want to see how close Charlotte is to the middle? Things like that, you do need geographic points for Charlotte, which brings in why we pulled in our zip code data. So on the opposite end, if I pulled off the hurricane, and I just have zip code points, what we're doing is just mapping the middle of a zip code. So if I dig into Charlotte and I've highlighted this for clarity, you can see the various zip codes across Charlotte. I'm here close to the university area, so 28213. And we can have different information about median household income, maybe how many people live here, and look at some of the attributes that we're most familiar with. So we have this shapefile, which is a polygon, as we talked about earlier, and we have points, these zip code points in the middle. And really what we're trying to do is see how they intersect. So with Tableau building in the intersect function, we can really lay these on top of each other and build a visualization where they interact. So initially when we started, we had zip codes of the entire US. And since we've selected intersect, Tableau is doing the work for us and saying, out of all of the zip codes that you have, these are the zip codes that fall within this polygon shape. This was very difficult to do pre-2019, I believe, in terms of Tableau. You had to pull it into a different tool. QGIS is the tool that I would use, and do like a spatial function called intersect, essentially. So again, a lot more easy, a lot quicker to insight. And what I've done here, since this data file specifically doesn't have any additional data, what can we do to make sure we get the data we want? And this is really where Tableau's approach to problem solving has been really helpful. Tableau typically takes complex things and solves them in an elegant way. So using a feature that's often not used as much, dashboard actions, there is the ability to drill into a URL. And what I can do is I can take information from my data set and pass it to the internet. So what I'm doing, I have a location here, datausa.io, and I'm passing the city and the state to this URL. And also the way that I can do this, if I'm just playing around and I'm trying to get into it, what I always start with is a Google request. So let's dig into Charlotte. I have my mapping. I'm looking at all of the zip codes. I have a little KPI below showing exactly how many zip codes were affected from a high level. And if my boss wants to give a presentation, she can select certain points, find out how many zip codes were hit if someone was curious about that area, and look at what was the total impact there. So I really want to know about the economic data here in Charlotte. And notice that I said in our data set, we only have geospatial data. There's no economic data here. I've simply embedded a URL here that shows information. So if I select a major city, and I'm going to just pick on Charlotte again, by clicking on this point, I can have a tooltip action. So I can use my old link and I can pass in variables. I've passed in Charlotte. I'm passing in median household income, and this is just simply a string, a parameter that I'm passing in. And then I'm basically letting Google do the work for me. So I'm saying, this is the median household income for this Charlotte region. If I wanted to look up the median unemployment or the unemployment for Charlotte, then I could do the same thing. Run that again. It's typing in Charlotte, unemployment, and I'll be able to get that rate really quickly. And it's always going to be the latest and greatest that's available. This is a good workaround for smaller shops that don't have a lot of data readily available or are not paying for some kind of subscription to data. You're getting the same information, but it's not in a CSV that you can easily transform. And of course, if you guys hire an intern, you can make them click the links and they can pull all of this data for you. But the reason why I showed you this is to show how you can start with geographic data, how you can come up with insights, and then more specifically, how can you create a useful and intuitive tool that can be used for later discussions. This tool can morph over time as new requirements come in, as new data comes in. You can iterate really quickly and make this something that can be really useful for your organization. So we did this pretty quickly. We pulled the data down, the zip code data from a CSV. We pulled the hurricane data down from NOAA. If there's another hurricane and we already have the zip code data, we can easily just replace the hurricane file that we have. And we can look at impacts of hurricanes over time. Maybe we come up with some kind of trend and see what the effects are over time for North Carolina versus Louisiana, or we can come up with some kind of risk factor for those places. All right. I know some people have asked, but I will get all the materials together and we will distribute them out afterwards if you want to play with some of this data and do it yourself. But there's a world of possibility here. We've talked about spatial joins. We've talked about how you can do buffer calculations in Rashid's previous example. And really this shows the number of things that you can do. You can get up-to-date information about the economy, any events, political data at a local level. I've seen people do things like tracking data. So of course I wear my Apple Watch nearly all of the time. It was a birthday gift from, I believe, earlier in the month. And it tracks where you are if you're going for a run. So I could even get down as granular as to say, what is my lat long for my run? How quickly am I getting to certain places? And if I'm tired, I can say, well, what is the quickest water fountain to me? Or what is the quickest rest stop to me? You can get very granular with this data. Another really cool thing that I've seen is from a social media perspective, especially with it being an election year as well. Twitter, when you post on Twitter, it does post your zip code. It doesn't post your exact location. But from there, if someone is posting about one candidate or another, you can really look at how things are trending left or right based on the tweet, whether it leans left or right in terms of if it was positive or negative from an NLP perspective. That gets more into your data science. But the world is your oyster once you understand the geospatial piece of it. You can solve a lot more analytical problems and get into some more data science oriented things. So with that, I'll open it up for questions. I'd love to hear from you guys about, have you used any of the features with buffer calcs? If you have any questions about geospatial data, and yeah, really just chat for the last 15 minutes of this chat.
All right, thanks, Darrell. Another awesome presentation. I'm gonna ask a question. Are you gonna post your dashboard to Tableau Public, or can you? The one you showed today?
Yes, so I will post the dashboard that I have to Tableau Public. I'm going to probably do that in the next week or so.
Okay, cool. All right. Yeah, if anyone has any questions, like William's point, feel free to, put them in the Q&A or the chat. William, you have any questions? We have Darrell. And again, thanks to, a lot of, great job, Darrell, and, definitely appreciate it, you giving us time. William, are you out there? I don't know if you're still out there. And maybe we lost William. All right, we have a question, Darrell. How many data points, latitude and longitude, would you say is recommended, when it comes to doing some of this geospatial mapping?
Yeah, so that is a good point. As you can see in my data set, I did show that, this is the zip code data for the entire US. What I would recommend is really focus on your user experience. I like to use the Russian doll example, and I've talked about this in a previous talk about comparative analytics to like North Carolina to the US or Charlotte to North Carolina. Really structure your dashboard in a way where you go from top to bottom. So what I would do if I was building a new visualization and I had zip code data, a lot of it, a lot of different points, I would not show that in the very beginning. I would aggregate up, give the user the ability to click and drill down to the level that is appropriate. Right now, we're currently defaulting to the zip codes that are within this hurricane path. Alternatively, we could have started with North Carolina, have some drill down functionality that allows us to click, get all of the zip codes for North Carolina, and then show attributes for maybe that zip code. So really leading the user through instead of fire hosing all of the data at once is a really good, not only visual, but data practice.
Okay. We got another question from Bill. You use dots to represent the zip codes. Can you also use fill map to see the area of a zip code on the map?
That is a good, so that's a good question. Essentially what he's asking, to translate that to what we've talked about before, is we know zip codes can be represented as a point, and we also know they can be represented as a polygon. So can we take two polygons and see where they intersect with each other? Um, the way that Tableau is basically doing this, and let me go back to my presentation, is from what I've seen with the way that they're handling this, is you're making it a point. They have a function called make point that you can put in the latitude and longitude. And if you have maybe North Carolina, we already know where it ends and where it begins. If you do make point for North Carolina, it's going to give you directly in the middle. It's going to turn it into a point before you can look at it. So typically for the relationships that I've seen, yes, you can represent two polygons on a map, but when you do comparisons for buffers, or if things intersect, it's typically going to be point to polygon.
Okay. We got one more question from AJ. How long did it take to do the analysis from end to end, would you say?
Yeah, so with this one, for the first time that I did this, this was pre 2018. So this did take some time. I definitely had to watch some YouTube videos on how to use QGIS and what spatial joins are, and taking into account the curvature of the earth for like calculating distance. But Tableau over time, as I said, they solve complex problems in an elegant way. And they've really made this simple with creating these functions. So there's a make point function. All you need is the lat long, and Tableau is going to do the work and the difficult calculation behind the scenes. The same thing with distance behind the scenes too. So for this one, to be honest with you guys, I haven't done this analysis since 2018, but I pulled this together probably in 2 hours. And the reason why I say that is because, I just downloaded two files. It's the shape file that I have here, that you can pull from the location that I have. You pull in your zip code file, and then you click intersect, and that's it. That's all.
All right, we got a good one for you. And Davey Moore said, this is a great presentation, just so you know, good job. Is there an easy way to show all states and have the dual access, the dual map at the zip level, filter by parameter, without losing all of the states that are not in the filter? Let me know if you need me to repeat that. I get what he's asking though. Can
Yeah,
you? Yeah, go ahead.
I think so. I think the best example of this, and I'm going to go on a little bit of a tangent, but yes, parameters would be the way that I would do that. Parameters and set actions, you can kind of control the user experience to show what you want to show. And the best way that I've seen this done is an if statement. So they're going to say, if this state is selected as a parameter, show all of the zip codes, else show the states. And this is just me spitballing, but that's how I would do that. And really, that's become a lot more useful depending on what version of Tableau you're on. 2019 and above, with set actions and parameter actions, open up a realm of possibilities to build dashboards that may have been built in 2017 that can be completely reworked. So I would highly encourage you to look up those two topics. Set actions and parameter actions would be the best way to do that.
All right. I'm gonna keep hitting you. My own
Sure.
questions. This one's from me. What advice would you give when it comes to some of these new functions in Tableau, like distance and buffer and make point and make line? Have you used all of those, to date, and kind of, do you have an idea of how and where you would use them? Because I don't find myself using them all that often.
Hmm. I would say the best thing for me, what's really kind of helped me out with the mapping piece, is really to study some of the examples that exist. Because once you see one example, your mind will start to spin and be creative and think about, how can I use this for my work? How can I use this for my personal? And some of the functionality that they build from a user experience way is really multi-step. And typically how I solve problems is, what's the way to visualize it? We're showing this as a visual, and the way some of these dashboards are designed is more from an experience perspective. I'll give you guys an example. This dashboard is built by one of the Tableau consultants. And this really highlights a lot of the points that we just mentioned, spatial joins, buffer calcs, and things of that nature. But it's really intuitive in the way that it's built. So by clicking on a point, the points that she's marked as stars, it's automatically going to switch the calculation. It's going to reprocess it and then highlight yellow the other points that it's near. And what she's looking at is the elementary schools and also the licenses for liquor stores that have been filed at a lat long perspective. So something like this can easily be applied to something else. If I have Airbnbs, how many breweries are close to me? If I'm looking, if I'm looking to buy a house, you know, what is the closest park to me? Maybe I want to be close to a mini park. So what is the location that has the most parks? Because I want to go to all the parks in a day. So really, once you start to spin off of that idea, you can start to analyze and decompose some of these dashboards that exist. Buffer calcs is very new. It's the 2020.2 feature. So even in most organizations, they don't have it, but I would recommend just practicing with what exists. And I'm sure you'll spin off something really cool in Tableau Public.
All right. And one last question. How can people reach out to you if they want to follow up with you, just give you some good feedback or maybe, poke your mind for some more good stuff?
Yeah. So during quarantine, I know a lot of us are, trying to occupy and find new hobbies. And one of mine has just been trying to work on my Tableau skills a little bit. But yeah, if you guys want to collaborate on a viz or talk about some of the things that I built in the past, yeah, feel free to reach out via Twitter or LinkedIn is like a really good way to reach me as well. And I'll try to find a way to get out this PowerPoint so people can access it. Maybe it will go in the Charlotte Tableau user group section, but yeah, these two places are best.
All right. Looks like we don't have any other questions. We're getting close to the 1 o'clock hour. I appreciate it, Darrell. Thanks again for all that you do. And in that vein, for anyone, that's part of the user group community, whether it's Charlotte or not, we always love this. If anyone else would like to, give a presentation in the future, feel free to reach out to us. Again, Darrell will give us the content from this presentation. We will get it up on our Charlotte Tableau user group page. Like I said, you can reach out to us on our Charlotte Tableau user group page. And it looks like from the poll earlier today, I believe Tableau actions, dashboard actions, parameter actions, set actions, URL actions, that's probably going to be next. That looks like that's what won. So hopefully, you guys will tune in for that one. You voted for it, so hopefully you will. And hopefully we'll do a good job of giving you some information around that. Again, I appreciate everyone for joining us. You guys enjoy the rest of your day. And Darrell, thanks again for everything that you presented today, man. Good job.
Yeah, thanks to everyone for joining us for lunch. Appreciate it.
You guys have a nice day.